Hi, I'm Peg Eaton. I'll be your guide today in this Tanzu Mission Control workshop. Been with VMware for over 13 years. I enjoy sailing all over the world. And I have these three terrific dogs that I go on a lot of camping trips with. I even bought them a crate to drive around America in. Today we'll be taking a look at the Tanzu portfolio just briefly, and then dive into mission control. And of course, this is really all about the hands-on lab itself, and we'll walk through the guided lab. The VMware Tanzu portfolio is a family of products and services for modernizing your applications and infrastructure with a common goal: deliver better software to production continuously. Think of this as a build, run, manage type of model. Today, our focus is going to be on Tanzu Mission Control and simplifying the multi-cluster operations in multiple clouds. We leverage the leading open source technologies in the Kubernetes ecosystem to build such a full K8s runtime platform for running the most mission-critical apps of our customers. All these open source technologies are built into the runtime platform for easy enterprise adoption and fully supported by VMware. VMware is also actively contributing to open source projects to make sure we're giving back to the community and further improving these projects, together with all the other open source contributors around the world. There are a variety of other hands-on labs that feature various products within the portfolio. You might take a look today at the observability lab, or Tanzu service mesh, or perhaps the build service. I won't read through all of these, but provide this as information for you. VMware Tanzu Mission Control is a centralized management platform for operating and securing your Kubernetes infrastructure and modern applications across teams and clouds. It provides operators with a single control point to give developers the independence they need to drive business forward, while enabling consistent management and operations across environments for increased security and governance. With TMC, your developers will be enabled with self-service access to Kubernetes for running and deploying applications. And at the same time, your operators will be able to centrally operate and manage your Kubernetes clusters no matter where they are at scale with consistency and efficiency. In addition, Tanzu Mission Control allows you to really strengthen your security over your containerized applications. It lets you easily manage security and compliance over your entire Kubernetes footprint. Let's dig a bit deeper into what Tanzu Mission Control offers to help you accomplish all that. There are two ways to bring clusters under management: provision clusters and attach clusters. Leveraging Tanzu Kubernetes Grid, you'll be able to provision Tanzu Kubernetes clusters directly via Tanzu Mission Control in the environment of your choice, and then manage the lifecycle of these clusters via TMC. At the same time, you'll be able to attach Kubernetes clusters to Tanzu Mission Control no matter where the cluster is, on vSphere, in public clouds, or through Kubernetes vendors such as EKS, AKS, GKE, or OpenShift. As long as it's CNF conformant clusters, you can attach them to Mission Control so that you can manage all of them centrally. When you have your entire Kubernetes footprint centralized under Tanzu Mission Control management, you'll be able to consistently and efficiently manage things like identity and access. You can also easily manage security and compliance by leveraging TMC's policy engine to apply consistent policies such as networking policy, access policy, registry policies, quota policies, security policies, and even custom policies to make sure your security and compliance guardrail is always in place across the clusters, teams, and clouds. With TMC, you no longer need to do these tasks manually. It lets you apply such policies quickly to a fleet of clusters and namespaces at scale. Tanzu Mission Control offers easy-to-use tools to help you manage configurations. For example, it integrates with an open-source tool called Project Sonaboy for cluster conformance inspection. We'll take a look at this during the lab today as well. In this way, you can quickly run an inspection of your clusters to see if your clusters are configured in compliance with the industry standard. Data protection in TMC is through an open-source tool called Valero for easy backup and recovery of your clusters and workloads. With a centralized footprint, one big benefit that you have is global visibility over all your clusters. We can take a look at observability and diagnostics through TMC as well, as TMC integrates with Tanzu Observability by Wavefront to offer deeper insights. We can also use monitoring and observability tools like Prometheus and Grafana if needed. Tanzu Mission Control also integrates with Tanzu Service Mesh for connectivity and traffic management at the microservices level. And integrations exist for Tanzu Application Catalog for app delivery and Tanzu Build Service for container creation and management. Earlier we said Tanzu Mission Control centrally operates and manages all your Kubernetes clusters and applications at scale. So let's take a look at how that's done. Starting at the bottom layer, TMC can provision Tanzu Kubernetes clusters, and TMC provides full lifecycle management, such as provision, upgrade, scale, and deletion of these clusters. The other way of getting clusters into TMC is by what we call attach, where we can attach any conformant Kubernetes cluster. Let's take a look at attaching existing clusters, and we'll be walking through this in the lab as well today. Attaching the existing clusters to TMC brings them under the resource hierarchy. On request of an attach, cluster agent service in TMC creates a deployment link to a YAML containing Kubernetes resources such as namespace, config map, custom resource definitions, OAuth credential as a secret, service accounts, and cluster agent deployments. On applying the deployment link on the cluster agent installs a cluster agent extension and custom resource definitions in your cluster. Cluster agent service and its extensions enable your cluster to communicate with Tanzu Mission Control. That is to send health information and manage your cluster. That is to enforce policies. The extension manager is one of the extensions installed on your cluster when you attach it. The extension manager oversees any other extensions the cluster agent installs on your cluster as a result of using the capabilities of Tanzu Mission Control. For example, when you run a conformance inspection on your cluster, the cluster agent installs an extension that runs Sonaboy. We'll cover cluster inspections a little bit later and have some work in the hands-on lab. Agents in the cluster either pull from TMC, such as pull policy changes or push TMC cluster health. TMC does not connect into the cluster. Sync agent watches for K8's object events and sends those back as the events are received. The intent agent, polling every 5 seconds, pulls intents, that is the policies. The extension updater pulls every 5 minutes, pulling extensions. Kubernetes is highly configurable and extensible. Extensions are software components that extend and deeply integrate with Kubernetes. Extensions deliver management functionality for the client cluster, health monitoring, conformance scans, policy configuration. Cluster health extensions push every 1 minute, updates to the cluster statuses back to TMC. And TMC supports attaching of clusters behind a proxy. Using the TMC CLI, you can specify the proxy details. Let's go layer up and take a look at the resource hierarchy. Resource hierarchy has organization at the root level. Cluster groups and workspaces are child nodes to the organization. Cluster groups allow you to organize your Kubernetes clusters into logical groupings, for example, to align with business units. Workspaces allow you to organize your managed namespaces into logical groups across clusters, perhaps to align with development projects. Policies can be applied to each node in the resource hierarchy. Policies flow down the tree and into clusters and namespaces. Let's take a closer look at the policy engine. As we mentioned, you can easily manage security and compliance by leveraging TMC's policy engine to apply consistent policies across security, access, network, image registry, and namespace quota policies, and even custom policies to make sure your security and compliance guardrails are in place across the clusters, teams, and clouds. TMC has various policies that can be applied to orgs, cluster groups, and workspaces. Some of these policies can be applied to cluster groups by platform operations teams, since these are cluster-wide configs that the policy will change. A few of these policies will be applicable to workspace names and will be used by application teams. Platform teams can use cluster-wide policies to define some ground rules, yet application teams have more control for the applications being deployed in namespaces. For a manageable security posture, VMware Tanzu Mission Control allows you to combine the members of your organization into logical user groups and secure those groups with access policies. You use VMware Cloud Services Platform to invite users to your organization and organize them into user groups. By combining users into groups, you can simplify access control by creating the policies that bind roles to groups rather than individuals. More importantly, you can also set up federation with your corporate domain that allows you to use your organization's single sign-on and identity source. Access policies allow you to control the permissions granted to the users of Tanzu Mission Control in your organization. Each object in the organizational hierarchy has an access policy where you can specify permissions using role bindings and associate a role with an identity. And we'll be taking a look at this during the hands-on lab portion of today's workshop as well, so that you get some experience in defining some of these policies. Next, we have cluster inspections powered by Sonaboy. Sonaboy is a diagnostic tool that makes it easier to understand the state of a Kubernetes cluster by running a choice of configuration tests in an accessible and non-destructive manner. A key goal for Kubernetes is portability. That's what makes conformance so important. Developers can build an application in one environment and then deploy it into another with minimal changes. Businesses can pick the hosting platform that best meets their needs based on application requirements. If the requirements change or new offerings emerge, the application isn't tied to a single Kubernetes environment. Without conformance, the key goals of Kubernetes, including portability and automated deployment, cannot be achieved. The conformance inspection validates the binaries running on your cluster and ensures that your cluster is properly installed and configured and working. You can view the generated report from within Tanzu Mission Control to assess and address any issues that arise. The light inspection is a node conformance test that validates whether nodes meet requirements for Kubernetes. Node conformance test is a containerized test framework that provides a system verification and functionality test for a node. The test validates the node meets minimum requirements for Kubernetes. A node that passes the test is qualified to join a Kubernetes cluster. The CIS benchmark inspection evaluates your clusters against the CIS benchmark for Kubernetes published by the Center for Internet Security. The CIS is a nonprofit entity whose mission is to identify, develop, validate, promote, and sustain best practice solutions for cyber defense. CIS has developed prescriptive tests for establishing a secure configuration posture for Kubernetes. The benchmark inspection scan in Tanzu Mission Control utilizes an implementation provided by Aqua Security called KubeBench. Support for the CIS benchmark inspection scan further enables you to tighten the security of your cluster within industry best practices. From the inspections page in Tanzu Mission Control, you can view a list of the most recent inspections that have been run against all the clusters in your organization, along with the results of those inspections. Terrific. Now it's time to start the hands-on lab portion of this workshop. And in today's lab, again, HOL 2234-01, Tanzu Mission Control, we're going to be looking at modules 2, 3, and 4, where we'll take a look first at attaching a TKG cluster to Tanzu Mission Control. We'll be working with some policies. I don't think we'll have time to go through all the full breadth of policies that are available, but we'll take a look at a few and you can finish up the lab later at your convenience. And we'll also examine conformance testing using Sonaboy. So just to be sure we're all on the same page here, you're going to be sure you got a browser and you're logged into your HL account using your email address. And once that lab is open, and I'll bring up a demo of that in just a second, I want to make sure that you're selecting on the browser the student check-in tab And at that point, when you enter your email address for your HOL account, you'll see two accounts created for you in Tanzu Mission Control. One is the essentially platform administrator account. The other one is a developer account. We're going to use a general Chrome account to get to the platform administrator account, and then I'll have you bring up the developer account in incognito so that we can go back and forth, taking a look at how different policies get applied. You want to be sure to execute module 2 before module 3 and 4, because we do attach a cluster to TMC and apply applications. So let's get going with this in the lab itself. Okay, as you bring up the lab, just a couple of comments. Probably want to extend the time that we're allocated to run the lab a little bit here, just to make sure everything is okay. And down here in the lower right-hand corner, you want to make sure you're paying attention to the lab status. That should be green, and it'll say that it's ready. While we're waiting, let's bring up this README file. And you may need to pull it onto your screen a little bit more centered. The file, as you may know, if you've used Hands-on Lab before, contains the account and passwords for the various tools that we'll be using during the lab. During most labs that I'm running, I like to keep it up on the desktop, able to click into it and find out the names rather rapidly. But just to give ourselves some desktop space today, I'll be sure and close that. So once we see the lab status marked ready, we're ready to begin the lab. And again, we're starting with module 2, where we're going to have an overview of the environment and use Tanzu Mission Control to attach existing Kubernetes cluster. So our cluster is ready. Let's go ahead and log into TMC. To do so, we need to supply the email address that we used to log into the Hands-on Lab. Just use my email address here, and you'll see that we have two accounts, as I mentioned before, the platform admin logon, as well as the developer login. We'll use this one a little bit later on. I like to bring it up in incognito, just so I don't have to keep continuously logging in and out with the various logins. So this one I'll just bring up in another tab in the browser. And when we need this one, I'll come back to this tab and open it in a incognito window for Chrome. Come over here. To our usual password. The usual cookie notification. And in this case, the tile that I want to choose on the VMware Cloud Services page is the Tanzu Mission Control tile. I'm now at the VMware Tanzu Mission Control page. Let's start with cluster groups. As we mentioned earlier, the cluster groups are used to group clusters and apply a common set of policies to the clusters. Clusters in a cluster group can exist in one or more physical environments and can be shared across teams. And we have a few default cluster groups created. Again, remember the 301 or the 3XX we're using for the platform admin, just again, for organizational reasons. And then 401 or the 4XX as for the developer cluster group. So let's click into cluster group 3XX, or in my case 301. And we see that we don't have any clusters here, so we'll attach a TKG cluster to this cluster group. And then we'll set some permissions and go through that. So as you can see along the left-hand pane, we talked a bit about cluster groups, the actual cluster list. We'll look at workspaces and namespaces as well, often used mostly in the developer kind of view of the clusters. Where we platform admin, we tend to look at this from a cluster or cluster groups view. We'll look at the actual workloads. We'll set some policies. This menu expands. We'll set some policies for the developers. And then later on, we'll run an inspection on the TKG cluster. Okay. Before we attach that cluster, let's go over to our CLI VM. And remember to load it and use the HOL user account here. Then open it. We just want to verify that our cluster is up and running. So we do that kubectl get nodes. Let me just expand this window so it makes it a little easier to read. Clear that out again. So as we look at this, again, we see TKC1, the control plane, and 3 worker nodes. So let's attach this cluster. Go to the TMC console and the cluster name. We know we want TKC1. And just click next and next again. And what we'll get is a command to install. Put that on the clipboard, this kubectl command that will install the cluster agent extensions that we need for TMC. Just cut and paste that essentially to the CLI VM. And we'll see all of these extensions being installed. And away we go. If during the cut and paste and you do this installation, you see errors that say that the server it exists or the role definition exists, you may need to clean the space, and that's indicated in your manual as well. There's a handful of commands that you run to remove any extensions that have been in place prior to you starting the lab. And if you try to attach the cluster twice, you'll need to clean it out so that you can reattach it if you disconnect it manually. So let's verify that connection, and success. We have connection to the cluster. So we come back to our, I guess we can view the cluster here, and it'll take a little while for these to all turn green, the checkboxes here. We'll come back to that in a bit. You need to hit the refresh button to get the agent and health extensions checkboxes all loaded. We'd have to do that a couple times. And then note the elements of the cluster along this menu bar. Take a look at the nodes, and we would expect to see the control plane as well as 3 worker nodes, which indeed we do. Namespaces that are part of the cluster. Notice that none of these are managed. This is the namespace that when we applied the agent extensions we saw, and we can go back to the CLI VM and verify that. And of course, workloads that are associated with the cluster. And any inspections, which we haven't run any yet, but we would see those listed there. Let's just do an overview of the cluster. Let's go over to our CLI VM. I'll clear this out. Let's run. I guess first let's take a look at the context just so we all are aware that we're in the TKC1 admin context. Again, the way the lab was set up, just to prepare that so you didn't have to set the context. But we can go to kubectl, get namespaces, and we would expect to see that TMC namespace that was created when we added the extensions to the cluster, TMC agent extensions. Excuse me. Let's change into the apps directory and create a let's just go ahead and create a namespace here. We'll create Pet Clinic. And then deploy it to Pet Clinic namespace. This is just one that's been preloaded. And we'll go back over here to TMC and see what's happening. Before we do that, let me just mention that if you haven't used Octant before, it can be pretty darn handy at being able to view deployments and what's going on with the overall system. And we see that we have Spring Pet Clinic running. Everything's green. And we have an IP where we could go and we could test that. And there we are. We have our little Pet Clinic app up and running. And what happens and what does this look like in TMC? So there's our Pet Clinic. It is not a managed namespace. Still have our control plane, 3 worker nodes. About workloads. We have to scroll down to see what's happening with that. And there's our deployment replica set associated with Pet Clinic. And we could go to Octant and do a comparison of that just to verify. And if you want to pull away some of the system elements so that they aren't, sort of in the way here, we could do that as well. We'll just leave them all there because it's kind of interesting to see everything. You can sort the namespaces and particular object types. You could sort by that as well. So again, just a quick overview of the cluster itself. Worker nodes and how it's performing. Let's go back to the CLI VM and remove that app, that deployment. And let's remove the namespace. And we'll look at that in a different way, perhaps later on. Back to Tanzu Mission Control. So we just explored attaching a cluster to TMC. Now let's take a look at workspaces and namespaces. We're going to create a new namespace within one of our existing workspaces that we've been allocated. It's been provided as a default to help you get going. So let's choose our platform admin account here. And then within this are different actions that we can take in the workspace. We can look at the policies associated with those or create a namespace, which let's do that. And let's create our Pet Clinic namespace. And we'll put it on our TKC1 cluster. And we'll just add a label this time. Pet Clinic namespace. Create. Certainly optional, but I thought it would be good for us to do that. And in this case, when we take a look at our namespaces, again, left-hand menu here, we'll see Pet Clinic, and it is a managed by and the workspace that it's allocated. So anytime you add a namespace, you have to add a workspace, just like for clusters. When you attach a cluster or provision a cluster, you have to specify a cluster group to go with it. Okay, let's start working with some policies. Expand the policy menu and go to assignments, and you'll see your different cluster groups that are here. And you can expand that a bit, and you'll see you have a cluster under, of course, we attached to cluster group my VMware 301 in this case. And if you check out the 401, we have no resources associated with that. Okay, so keep that in mind. And let's add some policies associated with the cluster group 301. And take a look at the policies that are already provided here. And we have organization admin, the top level, as well as these cluster group admin. What we want to do is add, these are the inherited policies and the direct access policies. We want to add a role for the 401 or the developer role here for with read access. If you pull down the drop-down menu, you'll see that we have a choice here, read access to clusters and their namespaces. So let's choose that. Cluster group, cluster view, and the user identity. And this is where we need to know or remember the, as a matter of fact, we can just use this if you have it or typed out there. We want 401. And so you'll add my VMware 404XX, whatever yours happens to be, and then be sure and save that. If we expand it, we can verify that we have both cluster group admin as well as cluster group view for the 401. Let's add another policy for that user. In this case, tell you what, I'm going to collapse this little guy to give us some more room on the screen. This time we want cluster access, including policies. Admin access, including policies. Save that one. Just try to verify that we have the particular access policies as specified in your manual. Just verify that. And then let's go over to Workspaces and add some policies. Keep in mind that when you think about clusters, most likely it's platform admin type of activity, and then with Workspaces, we're thinking from a developer viewpoint often. And we're going to add some access policies again for that user. We want to work with the cluster group for 301. Currently we have a workspace admin role, and we want to add read-write access. The workspace for that user. And remember, if you can't remember, I should say, the two different logins, you can always go back over to your check-in page, and the accounts will be there for you. Just take a quick look, make sure we have admin for 301 and workspace edit for 401. This will allow the user to create image, container, and network policies on that namespace, and the workspace and namespace policies are, think of it, as I mentioned before, more of an application-centric way to give a user access to the Kubernetes infrastructure. You think about this as compared to cluster and cluster group policy, it's more of an infrastructure way to define the policies, and both are important approaches. So now let's go over to our developer login. I'm going to open this in a incognito window. As I mentioned, it just saves logging in and out in two different areas. Hopefully I typed that in right. We'll see our tiles again when we get to the cloud.vmware.com page. And there's the mission control for us. Let's go to our policies. And if you notice at the organization level, we can't see that content. And we also can't see content at the cluster group level, again, as you would expect. What about at the cluster level? Oh, bingo, we start to be able to see the access policies. And of course, 401 cluster group admin was already set up as that cluster group, if you remember correctly. These were two different groups that we had set up, and this one has no resources associated with it, at least as of yet. Again, just being able to demonstrate the various access policies there at the cluster level. Let's look at the workspaces. We have some predefined workspaces. Our namespace pet clinic is there, but we don't have workloads. Workload is still assigned to the cluster itself. Let's create a namespace within our developer workspace area. Let's create the Kubernetes up and running namespace, kuard. And if we just switch back to our CLI VM for a minute, get the namespaces, we would expect to see both Pet Clinic and kuard there. And they are. And of course, we haven't done a deployment in either of these namespaces. We wouldn't expect to see anything. It's good to check. Let's take a look to see our namespaces that we created, Pet Clinic and kuard. They're both there. Let's deploy. Okay, let's go back to TMC and take a look at our namespaces, and we should see the deployments that we have done. That is in the workspace for the 401. How about in 301? We had access to it. Do we still have access? Yes, and we can see those workloads. Okay, terrific. If you recall, when we set up the permissions for the user, we provided, as a matter of fact, let's just go look at, let's go review the policies that we've set for the user. Recall that because where we are, you don't have, as a developer, you didn't have permissions to view the context of the cluster group level, but at the cluster level, policies allowed access to the particular cluster, TKC1, which means that the user can view all the namespaces, you know, all the namespaces that are in TKC1, as well as all the workloads that were in process. So now let's go back to the platform admin and remove those access policies that we put in place for the developer. Cluster group view, as well as cluster admin. So we delete those. And we delete that one. Let's go back to the developer role. And remember, before we could see all of the namespaces and all of the workloads. Okay. Our namespaces list is down to those namespaces that were created and are part of the TKC1 cluster that are managed and that there are permissions to view through those inherited policies. And what about workloads? There was a long list of workloads. And of course, now, again, we're talking about those workloads that were part of TKC1 and part of the permission set. Notice all the system level workloads and are gone from this. So very granular control. Let's go take a look at, from a platform administrator view, move back to that. Just going to close up. Give me 1 minute. I'm going to close the developer view for the moment. And let's go take a look at inspections, the idea of being able to run conformance checks. So our inspection types here, conformance, ensuring cluster conforms to the official Kubernetes inspection. Notice this one's really lengthy. CIS benchmark is quite interesting and runs pretty rapidly. We'll take a look at that, as well as a light inspection type. So let's take a look at the light. We have to choose the cluster we're going to run it on. Of course, in this case, it's TKC1. Just to give you a demonstration of it, it'll take a few minutes. You know, the option to delete, and then we'll also have the options to, from this menu, on TKC1, we can choose the cluster, and on TKC1, in this case, run various types of inspections. And there, the inspection completed. Look at the result here, one test, and we have conformance. And you can download the results of these inspections as well, or delete them. Let's choose CIS benchmark. That's running. I will note that there are some CIS benchmark tests that will fail here. But what's most interesting to me is that you get this list of the benchmark tests, and you can go through and analyze those areas where you want to align. There we go. So we have failure 11 out of 88 tests. So we click on that. Again, we get a result with 66 succeeded, some warnings, and 11 failed. So we can go through each of these and change. We have an opportunity to change our system and then what we're doing if we want to conform to each of these tests that happen to be here. It might be interesting to review. You can download and go through that inspection. Quick review of the items that we've covered today. Tanzu Mission Control provides a single control point for teams to more easily manage Kubernetes and operate modern containerized applications across multiple clouds and clusters. Tanzu Mission Control codifies the know-how of operating Kubernetes, including deploying and upgrading clusters, setting policies and configurations, understanding the health of clusters, and the root cause of underlying issues, creating a map from the people to the infrastructure. I hope today's lab session has been helpful. Thank you so much